All right.
Okay.
Very good morning, everyone. Very welcome to our webinar. We still have people joining little by little, so I suggest that we wait for another minute. But I have already started sharing my screen, so you will be seeing the cover page. Yeah, let's wait for another minute. All right, we have already 25 participants. That's totally fine. Very good morning. This is Eren Aksoy talking. Very welcome to our fourth webinar. This is a webinar series that we are organizing under the shelter of Horizon Europe project called ROADVIEW, which stands for Robust Automated Driving in Extreme Weather. So far, we have talked about different subjects relevant to autonomous driving, like perception, control, and so on, and standardization. Now, today, we want to dive into the details of extended loop systems. So we have we have we have many experts here as lineup speakers. Um, Before going through the agenda and so on, I would like to give some hints about the housekeeping rules. So this event is going to be recorded. So you should be very aware of this thing, because we want to publish the recordings on our webpage and social media channels. So in case you don't want to be involved, please let us know. So there is this email address here, and Julia is our technical support here. She's gonna share some links on the chat while I'm talking. Please let us know if you don't want to be involved in kind of these recordings. And we want to have very interactive webinar. So questions are a very important part of it. So we have dedicated boxes in our toolbar. So on the top left, you should be able to see this chat box where you notify us in case of there is any technical issues. So this channel is dedicated to this technically relevant issues. And we have another channel dedicated to only Q&A. So if you have any questions, technical questions, or scientific questions relevant to those talks, please direct it in this channel. Okay, so we are gonna collect your questions, and we are gonna have also a panel session where we will go through those questions and ask the speakers to answer those questions. So what's it about? So this is again a series of webinars on CCAM featuring the participation of global experts in the field. We would like to raise the awareness about CCAM solutions, because ROADVIEW is a CCAM supported project, and we are very much interested in solving those challenges that CCAM organization has already raised. We would like to also introduce innovations coming with the ROADVIEW project, which are highly relevant to those things that CCAM is highlighting. So raise awareness about the CCAM partnerships, because we have so many partners in the consortium that are part of the CCAM group. And we would like to also advise on standardization regularization requirements. We had a dedicated webinar on that as well. We would like to also present market applications of these innovations that we came up with in this project. If you are interested in these subjects, I highly recommend you to get subscribed to our newsletter and event reminder using the link that Julia is gonna share on in chat box very soon, so that you can get notified even earlier. All right, as I said, that's our fourth webinar, and we have the agenda here. And the first one is dedicated to myself. I am the coordinator of this ROADVIEW project, and I'm honored to have this opening speech here. so it will not take more than 5 minutes, I hope. Maybe I'm already going over time. We have many different speakers, so we are going to start with Jinjong Lee. I will go through the speakers later, but we have like 20 minutes time period for each talk plus 5 minutes Q&A. If you have a dedicated question specific about those talks, please go ahead here. But we have also dedicated Q&A session in the very end for 10 minutes to go over those questions that have not been addressed due to lack of time. Okay, and then we'll end the webinar around 11:30. And now I can happily go through the speakers. So this is myself. I'm an associate professor at Halmstad University in Sweden, and I'm mainly working in the fields of perception for autonomous vehicles and robots. And we have a speaker, Jinjong Lee. Very welcome. He's the head of Techways Europe, and he's also head of product development at Control Technologies. He's a senior research engineer at Hyundai Autron, and he's going to be talking about future of X-in-the-loop test benches. So his interests are covering EV ADAS test solution with AI, developing test strategies, and so on. And we will learn more in the upcoming minutes. And we have also another speaker, Professor Dr. Engineer Reza Rezaei. So Professor Rezaei is a manager also, manager modeling and simulation at a company in Germany. He is also a guest lecturer and honor professor at a university in Hannover in Germany. He has very many different hats indeed. He's an adjunct professor at the University of Alberta, and he has a PhD in Aachen University in Germany. And his interests cover AI, ADAS, virtual validation, and so on. Very welcome, Dr. Rezaei.
Thank you very much.
Next speaker is Dr. Dai Araki from Toshiba Corporation. He's a senior expert at Digital Engineering Center, Toshiba Corporation. He has an experience over 40 years in simulation engineering in the mobility and manufacturing sectors. And he has a PhD in information systems engineering from one of the top universities in Japan, Osaka University. I have been also there. It's a very beautiful environment. His expertise covers AI-driven cross-company collaboration in simulation engineering. Very welcome, Araki-san.
Thank you for your introduction.
And we have also Maikol Drechsler. So he's actually a partner of the ROADVIEW project. He's a PhD candidate at Technical Hochschule in Ingolstadt in Germany. He is also a visiting researcher at the University of Bologna in Italy. He has a bachelor degree in automotive engineering and MS degree in, again, the same subject, automotive engineering, but this time from Germany. And his research interests cover ADAS testing, vehicle dynamics testing, and validation of autonomous vehicles. Maikol, very welcome.
Thank you very much. Thank you for the introduction.
All right, that's all from my side. I mean, I did my best to give the very brief overview of the speakers as well as the agenda and the rules in the webinar. Given that, now we will start with Jinjong Lee. I would appreciate if you start already sharing your screen. I will stop sharing. All right, very good.
Thanks, Eren. So I hope that everyone can see my screen.
Yeah, we can. I can confirm that we can the screen. We can hear you very well.
Okay, thank you.
Thanks a lot.
Yeah, I can start. I can start my timer. I have a 20 minutes, looks like.
Yep.
Yeah, thanks for giving me a chance to share our ideas about how it looks like a future X-in-the-loop test bench system. So my name is Jinjong Lee. I'm representing the Techways Europe. And yeah, I'm going to share the idea for how to develop the standalone hardware-in-the-loop I/O solution, and then also how to utilize the system with how to develop your test case, automation tool chain with the AI. Mainly, I will introduce the my company, the Techways, briefly, and then I go through all the topic for the how it looks like autonomous validation and the hardware in the loop system, and then also for some foundation for hardware solution, and also the maybe today key figure, focusing looks like automation engine, and then how to do utilize the AI technology for our real validation world. I'd like to go with our company introduction. So the Techways, we are based on the South Korea. So the South Korea now is famous for the K-pop like BTS. So I believe you have some positive feeling for our country maybe. So and then we established 2003, and then we are almost now is 25 years now. And then we opened here is the European office here, the Germany. So I'm based on it's nearby the Lake Constance in the Friedrichshafen. So this is our company story since 2001, and then we one of the big milestone we achieve the 50 billion Korean won 2024 means around 30 million USD, and then 35 million 30 million euro, sorry. And around we achieved that one 2024, and then 2026 we open our European office to serve our global customer the better way. And we are mainly focusing on the automotive only. And then this is the global partner network. Since the last decade, we have a very strong partnership. Especially, we have a lot of partnership with in Europe, like Germany, and also we have some special partner for the electric vehicle. Even like for ADAS, we are strongly work together with Hexagon and the Konna technology here. So I was involved with that part even for the ROADVIEW project. So I'm very happy with this session actually. And then this is our brief portfolio for our automotive section. So the 90% revenue is only for the automotive section. Our main customer, of course, in the South Korea, the biggest OEM, and then also tier. So we have a very diversity domain in the automotive area, the test solution, like a green solution for the electric vehicle test solution, like a battery itself, and then also battery management system, converter, inverter, PRA, BDU, we serve all the test solution. And then when you look at the ECU test part, we have a long history with start from the body electronics testing and infotainment testing, also for radar, like radar, camera, ultrasonic LiDAR, and then also hardware in the loop, vehicle in the loop. And then mainly we are using our partner solution together with our own the product from the Techways. So today I'd like to introduce a little bit about what is our standard hardware solution. How do you maybe combine with one of your platform? Okay, and then today maybe I changed the topic to for the today. As we all know, for the autonomous driving, the testing is changing since the last years. We cannot handle everything with the manual testing for the on-road testing. Instead of that, we need to go through the virtual validation. So I believe the ROADVIEW is also one of the topic with extreme weather condition. You like to test everything, even like extreme weather with some unexpected situation. So we have a lot of challenge now. So how to make a virtual way to calibrate the testing. So I'm mainly focusing on the hardware in the loop testing for the topic. So we can discuss more how do we improve our testing strategy with the test system. So I like to go back to the hardware, the topic a little bit. You know, when you develop your hardware in the loop system, when you look at the left side picture, so many people using the industrial I/O, the data acquisition module or digital or switching module, but this system is normally not natively designed for automotive specific. So you need a voltage mismatching for the digital level, and then you need to develop the external, the signal conditioning to match the voltage level for the automotive. And also you don't have any power handling mechanism in your device like a KL15, KL30. And then finally, you need to develop, you have a your system is a more complicated complexity. And then also one of the thema the last 10 decade is the functional safety. So you need also all the functional safety feature need to do. So what we see from our experience, so you need a very automotive specific the hardware solution for your ADAS domain controller or any ECU testing. So this is the one of our platform for hardware platform. So we only design for the native automotive testing. For the any ECU, you can directly hook up with the native automotive level. So all the high current power distribution between the fault injection and also pretty low cost. And then you can combine with a different platform like a display vector IPG or NI. So that is one of benefit with our this standard hardware. So our motivation to develop design this one. So we like to serve a better way to automotive the customer, only who want to validate their ECU with the like to reduce the complexity to design their system. So with standalone architecture and then plug and play, as you can connect with the LAN and then CAN interface. So you can make a lot of scalability. You can choose this is one of our factor like 1U size or 4U size, but I think you can use the same module inside of a different size of rack size. So here is a brief specification. Like so here, you have a power distribution relay to simulate your KL1530, and then even you can measure your current like sleep current, dark current during your ECU going to sleep. You can measure directly with this module. Digital PWM, analog input, analog output. We are all designed for automotive level. So you don't need any external signal conditioning. You can directly use our system. So the experience with this one single rack, the size, the most ADAS ECU, AD ECU can cover for all the I/O signal. So that is our lesson learned from our project. So you can use our system like that way. So either you have a space or NI or vector or the other tool chain. So you can use our TPA for the electric signal connection with your DUT. And then finally, you don't need to change any hardware side the connectivity with your DUT, and then you can make a lot of freedom for the scalable for our system. This is we suggest our hardware platform when you develop the hardware in the loop system, even the other XI in the loop system. And then I like to go with the test automation tool. So you know the traditional test automation tool is always vendor specific. So you have a test automation tool from the display, test automation tool from the specific vendor. And then this test engineer always develop the test case, test scenario based on the tool dependency. So, and then they have a different type of language, different type of format, file format, and then finally he need a lot of effort if he like to change the other system, or maybe you need a independent engineer have to designate for the each system. This raise the cost and then raise your time. So so what we suggest when we have a project with the here, even you have a very nice hardware in the loop system, but without the test automation tool, you cannot utilize them fully. So our suggestion is using the developed from the Hyundai AutoEver, the X Studio. We have the work together with the Hyundai AutoEver pretty long time, and then their software is pretty good for the test automation as a backbone. So using this MobileGen X Studio, you can connect many other different hardware, the platform, and then you can orchestrate this as your single the position. So this tool is certified for the functional safety, and then even you can utilize for the same test case for the software in the loop and then hardware in the loop system. So and then you can reduce your manual working time a lot. So how is the idea behind for the X Studio? You know, we are using ASAM XIL standard. So either any supplier for Hill platform or testing system, when they provide the ASAM XIL API, the compatibility, you can manage from your side with X Studio for all the system in single place. So this is the idea behind from the X Studio, and how we integrate the test automation flow work with the X Studio. Okay, first you have a requirement document from your side. Maybe you have a configuration tool, or you have a written document with the Excel or Word file. So for example, here we have a very simple test case, the requirement from the like exterior tail lamp control. And then this one is first auto light sensor set the night mode, and then you need to wait 1 second, and then multi-left switch set the auto, and then you need to wait 1 second, and then finally ignition, and then tail lamp have to be turned on. Okay, this is the expected result. Okay, this is the kind of natural language, the requirement, and then we convert that one into the C#-based command. So here you can see the some function for the set wait, like on and turn. Turn is the on and turn is the the expected criteria like that. So when you have this reusable command, and then you can import the X Studio, and then from X Studio side, they have a different hardware configuration, like vector, like DSpace, NI, but they are still using the same command from the C#. So you don't need to change your test case, even you change your hardware configuration. So from here to here, you are using you need to config properly for the hardware port from the ASAM XIL, like MAP port or ES port, and then just you can reuse for all your test case with the same code. And then finally you can plan, okay, you like to maybe test this test case 1,000 times, repeat. And then maybe you like to learn the following test case, and then you can plan, okay, I like to do overnight testing, or weekend the run. So when you finish the plan, you just need to run the test case. and then you have the result after you come back to your the lab in the morning or Monday. So even you have a the good hardware system, without test automation tool, it's pretty hard to utilize your system well. So we strongly suggest always using this test automation platform, and then you can finally utilize your system. You don't need to wait until the weekend or night. You have to let the system work always. This is our suggestions. And then what we are doing now, so for example, now you have this very simple test case, but I like to extend this test case with the like ISTQB boundary condition, like a soft testing method. And then this boundary condition, this is a spec, 1 second, you have to wait, but I like to put the, maybe toleration for the 10%, like 0.9 or 1.1 or 1.12. I like to create more test case, like that way. And then actually you need a lot of effort if you like to write your code in your hand. So what we are doing now, so we train the AI agent how looks like this command set and how it works with our test scenario, and then we train the AI, and then finally you just need to write your command. I like to generate for this tail length condition with the AA situation, and then you have the executable ASM, the Exile test script base format with the C#, and then what you can do, you can just directly import that code into Access Studio, and then we reduce a lot of time to develop extend our test scenario. Of course, we discussed with him the whatever we like to maybe add this AI feature into the tool into the Access Studio, but currently we work as a separate the generator test case with the AI, but its concept works. So we just start with this AI the test case generation, but I think in very soon this AI agent can create all the test case based on your requirement. He can analyze your requirement, and then he can convert all the test case to our format with a C# based format, and then we can just run this test scenario into the Access Studio, our test automation toolchain. This is our workflow, how we support to the customer project. So I'm pretty fast run now. It's now I'm final
Time's up,
slide. Wow, it's very tough actually.
Yes.
So we are strongly suggest using the ASM Exile standard interface with the Access Studio, the test automation, tool chain, and with developed the hardware system with our TPA standalone native automotive specific design hardware system. And finally we like to move forward with the AI based test scenario generation. And then finally you can utilize your system fully without any rest from the system view. This is our view and thought. We support the project to the customer side. And so feel free to let me know if you have any question, and then contact me with any
Thank you very much,
topic.
Jinjong. That was fantastic.
Thank you.
So we can take one question if there is anyone willing to pose any question. Please feel free to raise the hand now. It seems like this is not the case, but we are gonna have a panel session in the very end there you can also ask questions. So then, thanks a lot. We then move forward with.
Eren, there's a question from Maikol.
Oh, Maikol, sorry, I did not.
There's no questions in the Q&A, but people who've joined, you're welcome to post any questions in the Q&A, and we'll have a look either now or then at the end.
Maikol also typed in the chat box, but please, Maikol, go ahead and ask your question.
Yeah, thank you. Thank you very much, Jinjong, for your presentation. The first question, it's about you put the ASM X in the loop interface. So in ROADView, we have been working a lot with ASM in general, Open Drive, Open Scenario, Open Simulation interface. Is there any interface or any description that is specifically for XEAL, or do you mean these different ASM standards together?
So it's even if you are using any interface for ASM standard, okay, maybe you can, from your software side, you can find the port support like ES port or MAP port, and then you can directly this one connect with the this test automation tool. Maybe we need to check your which tool you are using. So, but I can say not just about hardware. So if the software support ASM the interface, that you can directly control this software interface, this software tool, from the XStudio also.
All right, thanks a lot. Then we move forward and we continue with Reza. Reza, could you please start sharing your screen?
Araki will start.
Oh, sure.
Okay.
Then we start with Araki-san.
Not mine. So, okay. Hello everyone. My name is Araki from Toshiba Corporations. In Japan, I'm now traveling Germany, so that I'm now presenting from the Frankfurt. Okay. Just one introduction about our company. Our company is a Toshiba Corporation. Is maybe as you know my name, but it already having the history about 150 years and making the many business domains. I'm personally working in the simulation engineering almost 40 years. So that I have many experience in simulation in this picture, railway infrastructure, yes, factory, and everything is my understanding point. Okay. And today the topic is safety validation of automated vehicles. Okay, maybe as you know, in EU regulation 2022, it is defining the virtual testings to be the future certifications works. That means that traditionally their classification is mainly done by the real world testing, but the new regulations part 4 introduce this is the new definition about the virtual testings for the certifications. And actually this year is the first year for the virtual testing for the NCAP. NCAP 2026 is formally integrated virtual testing into the rating protocol, so that all of the manufacturers need to care about these topics, because the simulation works should be done by the manufacturer side, and show the qualification and validation results to the certification bodies. And the Euro NCAP is also announced that this way will be more becoming more wider in the future. So that's the autonomous driving or the advanced driving systems need to be care about more about the simulations. And in this year's NCAP 2026, this is a certification starting from the emergency braking system test. And they are defining the four type of the simulation test, car to car or the car to pedestrian test. And they already defining the KPI errors to compare between real test with virtual test. And in this case, they are defining the whole KPI to the timing of the warnings or the timing to the starting the brakings and the remaining distance, something like you need to compare the real test and the virtual test within this KPI error rate. And this is related with a previous presentations of Techways, and the generic framework is common. We need to combine the simulations of the environment, sensors, control vehicles, and some test scenarios should be put to the simulation framework and make the results. And we have some three open issues. One is how to achieve a collaboration in a simulation framework. And also the simulation works often handled by the multiple teams, OEM suppliers. So that how to achieve the collaboration is the one big issue. Second issue is the how to generate how to collect the enough test scenarios for the validation. The third topic is maybe major topics but we need to care about the comparison between real test and the simulation. So that the simulation needs the quality and credibility to the simulation results. And we are initiating this virtual homologation project by Prostate in Germany and Eren. And the last year, we are making the announcement to this new initiative at the last year's Prostate Symposium 2025. And then we started some discussion in the group between Prostate and the Eren. And we have accumulated several workshops for the event between Prostate and Eren. And this is the third one how this works is just held in this weeks. Okay. And the main focusing on point of this project is divided in three. One is achievement of common understanding about regulations to achieve some common what kind of the work or what kind of process will be needed to the statistician works. The second is validations of the simulations, mainly focusing on the comparison of the real test and the simulation test. We made several experiments to the sensor domain or the vehicle dynamics domain this year. And third topic is how to apply the AI to this satisfying works or the validation works. Okay. Yes, this is just a picture of the project structures. We will share the common challenges and they divided to ProStep teams and ESAM teams, and also some Japanese JAMBI. This is a Japanese consortium in model-based engineering is joining this teams, and we are sharing the topics to the three parties. And ESAM point of view, the last presentation that mentioned about the XIL, but in this case is we are asking the ESAM to the open simulation interface to connecting the whole simulation models in one, and also asking the one some task for the quantifying the simulation quality to the other. Okay, I will change to my hand to the Reza-san.
Thank you.
Much, Araki-san. So I'm sorry that my camera is not working today. So going forward, part of our project is to investigate the AI technologies and how it could help in the development phase up to the virtual homologation. So this is a demonstration showing different AI products. So here, relevant for our discussion is the IV Definition, which is an LLM-based product which can read, understand, and create test cases from requirements. And after having the test cases, test specification, this will go to the IV Mela, which I will introduce in the next slide. So the main task of IV Mela is to create scenarios from text or extract it from real-world testing, which we can then have the loop complete. So in principle, the IV Mela is working on one side the requirements definition, which is coming from the Fenian, and can create simulation scenarios. It means we have a first use case where we can give IV Mela a scenario description as a text. As you can see an example, this is a textual description of the situation where we would like to test. And in case of a scaling, if we have a multiple thousand textual description of the scenario, it's the powerful tool which can read, understand, and also make a check of the text if some parameters is missing. And after this processing, it can automatically create the simulation models in DSpace, simulation models in IPG CarMaker or Open Scenario, Open Drive. And this is to say the input for seal, heal, will, etc. So it can save the development cost up to 80-90%. And the next part, which is interesting, especially for the bad weather condition, extreme weather condition, is to extract the test scenarios from real world field testing or field operational test. There we can give the videos, CAN data, GPS, and there would be a combination of large language model, and also computer vision to understand the scene and scenario, scene understanding, scenario semantics. And then also in the same way, simulation models will be created directly from their test data. So with that, we can fulfill part of the homologation regulation, which is asking for evidence-based scenarios, which are coming from the real-world field testing. And it's very powerful tool. If you have software bug, or if you are bringing your car in another country where you would like to check if it works or not, and of course for the software update, you can check with the real world testing. Giving one demonstration where the first use case, creating scenario with the requirements work. So this is IV Definition, another tool which is before the Mela. So here we can check the requirements and creating at the end the test case, test specification. And this test specification will be then given to the IV Mela. So the Mela is in AWS cloud, and a communication with S3 bucket is possible, for the text and also for the field test data. In this case, we have a textual description, then putting in the run in the Mela, the text will be then understood. And here there is a possibility for the user on the right side to check if the scenario description is correctly understood. It's a kind of check, but also a kind of semantic description of a scenarios in a systematic way, that you have environmental maneuver, general setting, etc. So the user can check and also can change, edit, and modify the scenario. So for example, he wants to change the position, velocity, etc. So kind of modification, variation is possible. And after that, the modified scenario could be checked. And when then the user says, okay, scenario is correctly understood, then it can go and create the simulation model, which I will show in the next slides. The second and very interesting use case would be direct extraction from real-world field scenarios. So if you have a CAN data video, then you can give it to the Mela. So here we have a possibility in the AWS system to bring multiple scenarios into the scenario data bank. So that is also a nice feature of Mela, that you can keep all of the real world scenarios in the data bank that you can check. And this will then grow up during the time that you have a kind of scenario sets. So here the image or the video could be given to the Mela. It will be processed in the AWS cloud system. Then a kind of understanding of the scenario, scene understanding will be given, same procedure, so the user can check if everything is okay or not. And this is also a kind of combination with computer vision in order to, to safeguard the vision large language model, avoiding hallucination. There we have a kind of USB, a combination of computer vision and vision large language models. And after that, it's coming interesting part. The scenario is understood. And then we can decide to have a native DSpace model, native CarMaker model, or go for open scenario, open drive, which are the standard ASAM format. So this is an example where Mela runs DSpace CarMaker using API in the cloud, does the simulation, and giving back the simulation results as a video. This is for open scenario as ASAM format, and you can find all of the results always in the scenario data bank. And interesting thing is also here to change the scenario. It's afternoon to make it night, change the weather condition to rainy, and they're going into the more challenging scenario. And then asking the DSpace to create the model that you can see, okay, now a rainy road is simulated. It's principle the same, but the scenario is then now more critical. Yes, and this could be then every time changed, modified, and the user, can use this for differential hill testing. The idea is to have realistic world scenarios, as you can see here, from the test or even from the textual description. And that was in DSpace. Now it's in open scenario, open drive. And we do have also possibility with our engineering at IEB to create a map if we have a specific map data, or if we have a direct definition of the object list from the sensor supplier. So if the sensor supplier can provide the object list, this is also possible. And as mentioned, here's a summary. We can get DSpace native models, IPG CarMaker native models, and also open scenario, open drive. And this will give the OEM or the user the maximum flexibility to work with the state of the art of the simulation software. Okay, so Araki-san,
some short demonstration and the summary, making the summaries. The demonstration is that we are using the IB mirror, the Reza-san presented. This is the element to utilize the scenario generations. And we are demonstration that using the two system. One is a real autonomous driving control software, AutoAir, and also IP CarMaker to realize utilize the simulation, scenario simulation, and air vehicle and other environment simulations. And we, in this case, we utilize our DCB. This is a distributed simulation framework, so that this can enable to coupling the different simulations, crossover the network, so that these two simulation system can be executed at a separate place, at a separate company. And here is some simulation use case. That is we are running the simulation system in parallel, and the right side is the AutoAir, and the left side is the CarMaker. Is now in the second side, some people is parking, so that the AutoAir can automatically slow down the vehicles, and some pedestrians now start crossing the road, so that the AutoAir is stopping the vehicle, and also then after the crossing the pedestrian, they can restart the vehicle. This is a typical some NCAP test cases. Okay, I will summarize the questions. I pointed out the three open issues in the ADA virtual validations. And the top line is that we need to some collaborating or some integrations environment to combine the different simulation systems. Techways presentation also, I think, covered these topics. And the second topic is today's main presentation, how AI can be helped to reduce the workload for scenario generations. The remaining topic, and the remaining topics is how to achieve the measure the model credibilities between real test and the virtual test. And yes, now we are first step for the exam teams is try to defining some achievements, the common API for measuring it. Okay. Yes, please join our group if you're interested about this presentation. Please contact us. Thank you.
Thank you very much. That was very interesting presentations. We can still take some questions if there is anyone interested in the question. If not, I can start with one. What I like very much is this pipeline where you can give the camera canvas information also together with the camera information, and it can generate the scenarios. Now I'm wondering, what if we also wanna give the LiDAR point cloud data, for instance, can we generate scenarios given this point clouds together with, for instance, scene semantics, like say semantic segmentation results, object detection results? Can we do something like that?
So it's very interesting discussion point. So what we can do is to give the object list after fusion. So I mean, if you have a LiDAR point cloud, then there would be kind of fusion, right? So after fusion is of course possible. So before fusion, just to simulate the LiDAR is a very nice case study. So we are thinking. So if there is a possibility to do or to develop in a kind of project, etc., we are really open for that. It's a kind of future feature for us when it comes to the LiDAR simulation. So we are very interested in this point.
Very good, because we in the ROADVIEW project we have done that. So we have solutions where, given the raw point cloud data, you can get the semantics. Plus, you can also simulate the LiDAR, give it some sort of noise values. So noise may come from the weather aspects. So we have a dedicated group from the UK. So they were particularly working on the noise, generating noisy LiDAR point clouds.
Okay, it's very nice. So which software did you use? DSpace or any commercial software or your own software?
No, it was a university academic partner, so they developed this software in-house.
Yeah, very nice. And maybe one point, so I forgot to mention, so IVMela is in the AWS cloud, and we are open to share, to contribute in any in any research project or any POC. If interest, please contact me.
Thank you.
Thank you.
We can still take one more question if there is anyone. Yeah, there is, but it came to the chat box. Hi, thank you for your presentation. That's a question from Petros. Lucas, may I ask which LLM, VLM do you use for scenario map generation? Thank you in advance.
Yeah, so we do have a combination. So we have a LLM and Vision LLM from the from the providers like OpenAI and also Anthropic. So these are the major parts, and we combine it with computer vision and a kind of fine tuning. But to say the baseline is from OpenAI and or Anthropic.
Thank you. All right, thanks a lot. With that, we are done with this presentation. Now we oh, Maikol, you have a question?
Yeah, I would have a question.
Yeah,
really
please,
quick.
go ahead.
So just to make sure that I understand, so basically from the camera, you are taking the style of your scenario, or you're really getting the ground truth? So you're able to take positioning of the vehicles from the camera, or you always need to add the object list to it?
Yeah, it's a very good question. Both possible. If you have the object list, you can give. If you don't have an object list, then we have a Mela pre-annotator, which is not shown here. But then the Mela pre-annotator will detect the objects, will calculate the distances, and we published for JSAE a kind of comparison between the distance estimation from the camera base to the LiDAR ground truth. To make it short, Mela can also create the object list from the camera with using his own computer vision part as well.
Nice, thank you.
Thank you.
All right. Again, thanks a lot. Then we can switch to Maikol. He's our next speaker. Maikol, it would be great if you can start sharing your screen. And he's going to be talking about weather relevant, ROADVIEW weather aware X-in-the-loop test environment. Stage is yours.
Great, thank you very much. Thank you for the introduction. So my name is Maikol Drechsler. I'm from the Technikhochschule Ingolstadt, so University of Applied Sciences from Ingolstadt. From the research center CARISSMA here in Germany. So I would like to start with the objective, or what was our idea when we started the project. So in the whole ROADVIEW project is focused on the development of weather-aware driving, autonomous driving system. So we want to develop vehicles that can drive under harsh weather conditions. And one of the important topics inside of it was the development of a test system that we could also use for validating it in some specific weather conditions. So the idea was to implement and to validate this X-in-the-loop system in which we could reproduce the extreme weather conditions which we would get from collected data in a specific test conditions, so in controlled environments. So we would also, and we also want to validate somehow. So we needed to define some metrics to do this validation and define a methodology to do this comparison between the real world and the simulation. So since we wanted to have exactly the same scenario in both cases, in both sites, in the virtual world and the real world, we start by rebuilding our static world. Just one point about the last slide that's important that I'll be presenting, but this is a huge work from different partners that have contributed on it. So this is not just my work, and I'm also glad that we have this opportunity to work together. And then we start by the test track here in CARISSMA. So basically, we have using LiDARs, we have scanned the whole test track, and we also have used total station to make the measurements, try to make it as best as possible regarding the precision. And we end up with some centimeters of error when comparing the final meshes and the high precision LiDAR point clouds that we have collected. And this static world was then integrated and inside Carla for doing the tests. We have not done this, what we call digital twin, but the static word only from CARISSMA, but we have done it for all over Europe, also from Cerema in France, from Lapram Proving Ground in Finland, and also in Turkey from a public highway. For the validation part, we have mainly focused on CARISSMA test track, since we could reproduce it in easily in our test track. So the real test could be easily reproduced in the real test track. And we have also done more or less the same approach for the dynamic targets. So including the Eagle vehicle, that's in this case is the BMW M8, and also for the different targets that we wanted to use in this testing campaign. And in parallel, we also collect data under controlled weather conditions. So for doing that, we use mobile facility, rain facility, in which we first measure it. We define it how we should build this facility in a way to get the controlled measurements of the intensity of the rain. Because the main point is that most of the simulators that we have nowadays, you can set the rain intensity between 0 and 100%, but you don't have a direct comparison to the real world. And here what we wanted to achieve is that we want to set 10 millimeters per hour rain intensity, and we would have at least a statistical approach in which we could, or physical approach that we could achieve exactly the same characteristics of our camera sensor and LiDAR sensor. So we also went to France, and in Cerema we also have done this data collection under fog conditions. and we also have collected open world data from snow. So we have done this data collection with 2 different types of LiDAR, so the rotative LiDARs, MEMS LiDARs, also for the radars, thermal camera, and RGB camera. What you can see here, it's clean weather, but we also have done them for different intensities of rain, different intensities of fog, and also the snowy conditions. And then just capturing this data was not enough. So what we have done, we have analyzed this data and we understood how this data was influencing each one of the sensors. So how it influences the RGB camera, how it influences the LiDAR, and how it influences the radar. And then we have modeled it. So here you can see some examples of camera noise models and LiDAR models. So on the very left, the clean weather. And when you have, you can see that both the camera and LiDAR behave completely different when we have these different weather conditions being applied to them. Once we have the models and once we have the scenarios, we want to be able to test the algorithms that we are developing in ROADVIEW inside the final control unit. So the same control unit that will be put inside the real vehicle, mainly because in the end we want to do this comparison, so we need to have everything already embedded in the car. So then we have applied 2 different approaches, so the hardware in the loop and the vehicle in the loop. The hardware in the loop is what you can see here. We have cooperated a lot with Conrad, who provide us a direct data injection for the camera. So for direct data injection, it means that we are getting this data directly from the graphic card from the computer that runs the simulation. This equipment will convert this data in the same format as the raw data that will be injected in the control unit, and the control unit see this data as it would be data coming from a real camera. For the radar, we have used another approach that's over the air. In this case, we have an anechoic chamber. Inside this anechoic chamber, we have a real radar mounted on it, so the control unit will be receiving this data from this real radar, but it's being manipulated. So we send information to this to the antennas on the other side, and these antennas are able to manipulate the electromagnetic waves and generate false objects for this radar, which will be injected then in the control unit. In this way, it will be like a VR glass for the vehicle. So the control unit will be seeing this virtual environment for many different ways. We also have simulated the LiDAR, but since there is no direct data injection or over-the-air method for the LiDAR, we have then simulated this data and send it directly to the network, to the control unit who was receiving this data. So here we can see a little bit deeper what I was explaining. So basically, on the left side, we have the simulation computer in which we run Carla. So since it was a public project and we wanted to have it easily to be being published and to being shared between the partners, we decided to use Carla, that is an open source simulator. Inside the Carla, we have the sensor models, that some of them that we have developed in-house, as for example, the MEMS LiDAR. And this data then is sent through a bridge that we also have developed here in C++, so that we could achieve the performances that we need. We have the simulators that I just explained to you, and this data then go to the control unit, and in this case was NVIDIA AGX drive. The control then from this control unit will send the data back to the host computer, in which we run then the vehicle model that we also have developed here. We have parameterized here, and we send this data back then to the simulator where the scene is being played. So we calculate the position of the vehicle, send the data to the simulation calculates new data from camera, LiDAR, and radar, and send it back to the control unit. For the sake of comparison and trying to understand which will be the best method or what are the limitations of each one of the methods, we also implemented a vehicle in the loop. In this case, we brought all the simulation to and emulation part to inside of the vehicle. So we have mounted this system that you can see on the left side, which the simulation runs inside the vehicle, and it controls or stimulates the control unit that directly actuates the vehicle in this way. So in this way, we change the vehicle dynamics model, and we had the real vehicle, which drives in an empty road, as you can see in the right top image. The vehicle is driving autonomously, and it brakes to this target that you can see in the monitor inside the vehicle. So basically, it reacts to the virtual entities. So the application is more or less the same. The only thing is that we don't have anymore at the bottom the vehicle dynamics model, and we also don't have the emulators because we don't fit over-the-air anechoic chamber inside the vehicle. So we do the directly simulation of all the sensors. We inject them in the control unit, and we directly take the positioning of the vehicle and then send it back to the simulation computer. Also, to highlight what I have been talking before, we try to make as much as possible everything conform with the standards. So we have been using OpenDrive to describe the map, open scenario to describe all the scenario. So everything that goes around the vehicle, the ego vehicle, and for doing the data exchange, every time that possible, we are using open simulation interface. That it's a way to describe the message that will be exchanged. So then, for doing the validation, as shown in the regulation, we should do it in a stepwise way. So we need to start validating our subsystem and go to vehicle system validation, then sensor validation till we can validate the whole system. So for that, we first start validating each one of the models. So we validate our vehicle dynamics model that we have developed inside the project. We have validated our camera model using ISO 12233 targets that basically are usually used for the validation of the performance or evaluation of the performance of cameras. Here we have implemented them in both worlds, real world and simulation. And one interesting fact that we see is that basically on the top, you can see that the proposed model that we have compared to the default model that we have in Carla perform much better regarding the colors, regarding the gray patches that you have in this target. But when we evaluate the perception system, it doesn't perform so well as expected. So it doesn't have the same correlation. So in this point, we need to start looking what are the features that the AI uses in our camera and our LiDAR data to collect the data. And more than they need to look similar to us, the most important thing is that they need to look similar to the AI system. So we need to try to understand what are the features that the AI is looking inside our sensors so that we can reproduce them in simulation. Something similar we have done for the LiDAR model, that we have validated the scan pattern that we have created. So on the right side, you can see the real and the simulated path put on top of each other. And then we arrive to a validation of the whole system. So we have conducted the same test in real world and the simulation. And we start seeing some differences about between them. So basically, we have done 3 different test scenarios, which is this car stoppage, so car-to-car rear-stationary, the rear-ending cap scenario, the pedestrian crossing, and also the bicycle crossing. So just taking some data so that we can start understanding some stuff. So we can see that harden the loop, when clear weather, reproduce really well the real behavior. Vehicle in the loop, not so much. And when we go to rain, and so both levels of rain that we have tested, we see that the hardened loop didn't detect the pedestrian basically, or the vehicle in this case. But evaluating this, we can see that the case is that in the simulation, so the perception system that we're using was state-of-art, out-of-the-shelf system that was not prepared for rain conditions. So then in the virtual environment, we have rain in the whole test track. In the real test track, we have the rain just in a specific area. So in this way, the vehicle in the virtual test was braking much earlier. So due to that, it was not detecting the object at all, because it was working much earlier than that. So this also brings us to think that a directly quantitative evaluation sometimes is complicated, because despite that we have the same subjective reaction in both sides, just a number, it's quite complicated to evaluate here. And then also we just went to check the behavior of the vehicle. So in real world and the vehicle dynamics, so the real world and in the vehicle dynamics model, the behavior of the vehicle was similar. So inside the limits that we define. So with that, we have seen that the most challenger was on the perception system. So most of the time we can focus it on hill testing, because the vehicle dynamics doesn't play a so significant role, mainly when testing these low velocities that we use in the urban scenarios, for example. We also have evaluated the performance of the systems. We see that Carla has some limitations, mainly when we start applying several sensors. And in this case, we have a really bad performance for fog, but we solved this change in the parameterization methodology that we have used. And we achieved then the 10 hertz that we wanted. That is basically the same frequency that the real sensors are sending when we reduce a little bit the resolution of the LiDAR. So finally, as a conclusion, so most of the things we already discussed, but some challenges are that for doing emulation, for example, when we want to do direct data injection of different sensors, we don't have it standardized interfaces, so it's quite complicated to inject data, for example, inside a sensor and try to understand how it will behave inside the X-in-the-loop system. There is no standard model description, so it's super complicated to port the models from one system to another. We are still facing some limited performance of the simulator, and we need to focus it on this recognition of the features of the AI, or the features that the AI used to recognize inside to recognize the objects inside the simulation, so that we can improve our simulators for the AI or for the perception algorithms and not for human-wide eyes. What I also discussed, that Hill is much more practical than View, mainly for the development process. So View will be a benefit once you have the whole car full mounted and you want to do a homologation process, for example, then you can conduct the tests and the real test track and just play like a VR system for the vehicle, in which you will be reacting for the virtual environment without needing to model your car every time. But in general, since the most big challenge is still on the perception system, so how do we stimulate the perception algorithms in the proper way? The hard-in-the-loop will be enough for the tests. And with that, I finish my presentation. Thank you very much.
Thank you very much, Maikol. We have some questions. So the first one is coming from Araki-san. So are you collaborating with Assam OC for high fidelity sensor simulation activity in Assam?
Yes, my question is coming from my presentation. Now we are Hivish in the prospect and Assam OBI for OZ is the collaborating. Now the Assam OZ side is defining some generic framework or the architecture for the sensor simulations like your figures. And also, Hivish product teams is focusing on the experiments of the comparison between real sensors and the simulations. Yes, so that and also my questions coming from this party.
Okay, great, thank you. So basically, we have collaborated with Open Simulation Interface a lot in the past, mainly for the description of the vehicle data. So when we start working with the car, there was not exactly the data that we needed for describing the vehicle motion in the way that we wanted, and we work with them for doing that. but we are not involved now in this part of high fidelity sensor simulation.
Yes, it's a very new project they are launching now, maybe last year, so that, yes.
Okay. Yeah, I didn't know. Maybe we should join them.
I can contact with you, and yes, this team, yes.
Thank you. Yeah, what we are collaborating with them is in the QSQ. There is this quality for simulation something. So in which they are trying to define how do we compare it? How do we compare real world in simulation, or how do we measure the quality of simulation, fidelity, credibility of simulation? And this is a work project that it's ongoing now, and we are working on them based using also the results that we have in ROADVIEW. But yeah, happy to exchange about the new OSE.
Yes, I also.
Group.
Thank you.
Thank you.
We have one more question. Which control software you use for brake control?
Yep. Thank you for the question. So in this case, we have used our own decision-making system that was quite simple. So basically, it was just driving the vehicle. So it's a lane follower. So it was following the specific open drive map that we had. And then in case of any, or based on time to collision, it was decided by the trigger of the emergency braking. We still have some limitations on this vehicle, basically, so we can achieve only 4 meters per second square deceleration, so we cannot really perform a emergency braking maneuver. We can smoothly brake the car, basically. But yeah, it was an in-house development, since it was not the main approach or the main goal of the project to validate the real system. For us, it was good to have in the first instance something open so that we could try to understand how the simulation or emulation was affecting the whole system.
Thank you. So it's also somehow related to the HiVish project. We are discussing with Araki-san whether we integrate AutoWare from Tier 4. It's also open source control system, so could be an option. Thanks, Maikol.
Yep, you're welcome. Also, we now started integrating AutoWare in this project and in this vehicle, to be honest. And but since we had our own perception coming from ROADVIEW, and this is basically what we wanted to test, then we just decided to just integrate some simplified decision making to see how it will, how the weather will be affecting the performance of the decision of the perception system.
Yes, thank you.
Thank you.
All right, thanks a lot. Is there any questions? Seems like it's not the case. Actually, we are done with all the all the talks.
Jinjong has a question.
Jinjong has a question. Again,
which level of vehicle dynamics model is used for the hills compared vehicle in the loop system?
Yeah.
So the vehicle model was 11 degrees of freedom. So each one of the wheels has 1 degree of freedom. The engine has 1 degree of freedom. And then you have the 6 degrees of freedom of the vehicle, which we have developed in-house. Why we have done so? Because we wanted to develop a parameterization methodology, so a parameter estimation methodology in which we drive the vehicle. So there are a lot of parameters that are difficult to be measured, like suspension-related parameters. And we wanted to drive our vehicle in the test track, collect some data, and based on that, use the optimization methodology to find out the parameters that we need to use for this model. Due to that, we have integrated in the Python so that we could easily use the libraries to do this this optimization methodology and run it fast enough so that we can obtain the parameters as fast as possible.
Yeah, thank you, Maikol. Because I'm very interested. You mentioned about the more practical with the hardware in the loop system than the wheel somehow. So I'd like to understand. Maybe what do you think if we simplify the vehicle dynamics even more, like because many times our partner is a little bit struggle when about the vehicle dynamics part when develop the hardware in the loop system. Maybe if they focusing on the ADAS CCU, maybe if you suggest the perception is the most critical part, maybe they can simplify the model, maybe commercial vehicle model they can utilize. And maybe it works also to validate their ADAS system with some simple vehicle dynamics model.
Yeah. I mean, this is the point. If I would be build it today again, I would simplify the model for sure. So I believe that for our use case, but I mean, it's important to highlight that we are driving until 50 kilometers per hour, 60 kilometers per hour. So we are never achieving the limits of our vehicle dynamics model. And also we have acceleration limitations. So we cannot drive full speed or giving full gas or need a full brake on it. So for this, the vehicle dynamics could be super simplified. As soon as you want to drive 200 kilometers per hour in the Autobahn in Germany, then of course the vehicle dynamics will play a much more important role. But for urban scenarios, for sure, the vehicle dynamics can be super simplified. And the important part of the vehicle dynamics for me is that longitudinally behaves proper. That sometimes can be a problem because somehow you need to model the engine, powertrain, gear changes, that it can be tricky, complicated, because you don't have access to this. You don't know exactly how it works. But what we notice that, or the approach that we decide to use is basically we optimize the vehicle dynamics for the test that we want to conduct. So I want to conduct tests for 30 kilometers per hour, 50 kilometers per hour, decelerating in this way, in that way. So I collect first data from the vehicle dynamics itself. Don't need to neither drive autonomously. I optimize my model for that. And even if I'm not describing all the physical possible things that are necessary, this optimization will also trick the model so that the parameters, for maybe if you put a latence of the brake, for example, and it doesn't come from the brake, but it comes from somewhere else, this optimization will take these parameters in consideration so that in the end you have a similar behavior of the vehicle. That is the most important part, right? You don't need necessarily that every parameter has the specifically respective physical value. But it's important that the whole system, whole vehicle works in the proper way when you're evaluating the result.
Yeah, thank you.
Thank you, Jinjong.
All right, thanks a lot again. So we are gonna now have this a panel session where we can. I would kindly ask every speaker to turn on the cameras and answer questions if there is any. But before that, Julia just shared a post in the chat, which is very important. I think I should just highlight that one more time. So we are going to release the recordings of this webinar most likely next week. And if you are willing to learn more about our solutions in the ROADVIEW project, you can also have a look at our demo video that Julia also shared the link in chat. We can now pose questions in this panel session, but since there is no more questions, I would like to pose one. And I wonder your general view about this question. So I would kindly ask you to comment on the use of generative AI, because we have seen some interesting talks where AI is basically used to generate scenarios given some information, sensor data, either text or video. But apart from that, can you please let us know what are the directions that we can use generative AI to make the testing and validation more meaningful? Let me be more specific. Do you think we should use generative AI to simulate the sensor data to create new scenario cases, or what else can be? I hope it's clear.
Yes. So yeah, I assume the question is related to me. Yeah, so we can use the Gen AI to define new test cases. So for example, asking a Gen AI, it is also partly implemented in Mela to say, okay, which weather conditions could be difficult or challenging for the ADAS system, and propose multiple to say relevant test scenarios. This is one point. The second point, which we will release soon in Mela, would be if you have a long video and you say, okay, in this long video, I do have some challenging situation, but also some normal condition. I just want to cut the long video into multiple clips where I can extract multiple scenarios from a long video. For that, you can also use a Gen AI to, in combination with computer vision, in order to evaluate, to say, multiple parts of the long video to create clips and relevant scenarios.
Oh, that's very interesting.
Yes, yes. And maybe the third would be a kind of search in a data bank. So if you have a huge number of scenarios, clips, you can ask, then use also Gen AI with some embedding to search and propose relevant scenarios from the real world testing, which are available. So it's the kind of creation or proposing relevant test scenarios. Yeah.
Very good.
I have another comment
Please.
about the AI. Yes. Today, the Jinjong-san is presenting his presentation about the automating the testing. Because we need to handle the different simulation systems to combine, so that's some automations is necessary. So that the AI is maybe helpful. On my side, I am trying to the AI to do the calibrations works for the control parameters. That is also the very AI can be assisted where, so that because the AI can soon understand the background knowledge about the models. So that in my experience, that very powerful for the yes, calibration works. They can immediately propose to the which parameter, which controller is essential for the is control or the yes. So that I think that kind of view, yes.
Yep.
Yeah, is very powerful. Yes.
Thank you. Jinjong, would you like to comment? I will continue. You're muted.
I'm sorry.
No worries.
I think you can utilize even the AI for the, as I mentioned from my slide, that we like to extend with the current test case, test scenario. So actually, it saves a lot of cost and then effort. It means that maybe in the future, maybe we can just create everything with the AI. That is our future. But yeah, now I feel more practically, we can utilize AI for extend our current test scenario to maybe from 1 to 1,000. So easily you can explore the test scenario. Yeah.
Mm-hmm. Very good. Maikol, would you like to also comment on that?
Yeah, I mean, I think that everybody already say a little bit about it, but I also believe that, I mean, when I think about generative AI for testing, I mainly think about generating or expanding the tests or by adding different weather conditions or by adding new objects. So you can collect the data from the real world and say, look, now in this camera scene, instead of having 3 cars, I want to have 4, I had to have 5, or you can even challenge the generative AI to generate scenarios, maybe in a kind of reinforcement learning way, and you challenge it to generate cases in which your system will fail. So you can start having more crazy scenarios, more challenging scenarios, and then you can evaluate if they really make sense or not.
Yep. Learning from failures and so on. I see. All right. Thanks a lot, everyone. I really appreciate the time you spent on that, and the slides were very descriptive, very instructive. We appreciate all that. And with that, we are ending the webinar. And thanks a lot again. If you are willing to see the recordings, please get back to our webpage next week. And also there are some more useful videos. I wish a wonderful weekend, which is approaching. and have a great day today.
Thank you very much. Bye-bye.
Thank you very much.
Thank
Bye.
you.
Thank you. Bye-bye.